One of the things that we used for verifying Ohm's law was VI graph. Let's understand about VI graph a bit better. It's going to help us understand the concept better and also answer quite a few tricky questions. First thing is VI graph stands for voltage, current, graph. So always remember, whatever comes in any graph name, the first thing that whichever comes first, that is your y-axis. That's plotted against the y-axis. And the other one is plotted against the x-axis. Okay. So basically VI graph. So the next question of any graph is the slope. What does the slope stand for? We know that slope is change in y-axis divided by change in x-axis, right? So this is read as delta, which means change. Okay. So if you want to recall, it is y2 minus y1 divided by x2 minus x1. Now, so along the y-axis, we are looking at voltage, change in voltage divided by, along the x-axis, we are looking at current. What is voltage divided by current? We know that from Ohm's law, resistance is equal to voltage divided by current. So basically, this will be equal to slope is equal to resistance. Okay, the slope of a VI graph will give you resistance. So let me explain it a bit with an example. So meaning of the below graph in terms of resistance. So I have two graphs along the x-axis. It is running from 1 to 10. Here too it's running from 1 to 10. Along the y-axis, this is also 1 to 10 and this is also 1 to 10. But here the slope is gradually increasing compared to this, right? This is slowly increasing. This is increased quite a bit. Now, what does it mean? Well, one thing is that if I find the slope of this particular graph, I'll get a resistance. We'll call it as 1. Let's call it as 1. And over here, let's call it as R2. The question is, which is more, right? What is this? What is this graph telling? This graph is telling that for a small change in voltage, right? We have to look at y-axis. For a small change in voltage, I have a huge current. While for a big change in voltage, I have the same current. Means what? Again, I'll repeat. For a small change in voltage, right? This is the small change in voltage. Change in voltage. I have a huge current. Okay. This is a big change. Change in voltage. I have the same current. Okay, of 10 amperes. What can you tell? What can you tell about the resistance? R1 is it lesser than or greater than R2? It's lesser than R2. Or am I wrong? Think about it. Yes, this is correct. R1 is lesser than R2. Is it not? Because we have small change in voltage and you have a huge current coming out. Means what? There's less resistance. Right? While you here for the same current, right? These two are the same current, both are 10 amperes. I need a huge voltage. Means I need a lot of push. Voltage is nothing but push, is it not? The push is huge. Means what? Resistance is huge. Okay, because with so much of push, we are getting the same current, is it not? So this is the whole idea of VI graph. So remember, this is what they'll ask mainly about the slope. What is the slope of VI graph? It gives you resistance. And the next set of questions are like this. It can be two different graph or the same graph. Generally, actually, they give in this way. They'll ask this is R2. This is R1, which has more resistance. Right? They ask such questions. Okay, so pause and make a note of it.